All right, this is one of the last ones we got for the evening. It's not too bad, but we'll do it together as usual. We will refer to figure 230.121. A safety switch is installed near the motor with the maximum permitted size dual element time delay fuses, DETD. Exception 1 was used in 43052 C1. You can read that for your pleasure, but there's not much to it that really pertains to this question. When the smallest permitted circuit conductors are used between the switch and the motor, the smallest size EGC permitted is blank gauge. Okay, a couple pieces of information and why this one probably kind of threw you off a little bit. One, I want to reassure you that we do have a whole week of motors, hermetic compressors, 430 and 440 coming up in the fourth quarter, so don't stress on it if you're still struggling with these a little bit. We got some time to reinforce the topic. Okay, but we are doing a 2-pole breaker in a 120, 240 volt, 3-phase panel. Okay, what that means is this is a single phase motor. Okay, why we're installing a single phase motor in a 3-phase system, I have no idea, but we are stuck by the bounds of the question. So just make sure you read that twice and answer once, because probably the biggest problem people were having with this one is they were sizing it based on a 3-phase, right? We can also reinforce that here. Phase 1, it's a single phase motor. Horsepower, 10. Let's go find this motor. 10 HP. I'm going to write it right there. 10 HP, single phase. Let's head over to our charts. Remember, for motor sizing considerations as far as overcurrent protective device and conductors, we are going to use the charts in the article 430 in the back of 430. So we are going to cruise all the way back there. I'll head to 440 and then scroll up a little bit. We have two that are super pertinent to us and come up a lot. That's going to be 430 250 for 3-phase and 430 248 for single phase. This question specifically asks about the single phase. And at the upper end of that spectrum is going to be a 10 horsepower motor. We are operating it at 230 volts. Remember, those voltage ratings are going to be nominal. Okay, and you can get that information right up here in this last sentence. Okay, that 230 rating that we're seeing here could be anywhere from 220 to 240 volts. Okay, so that's how that nominal rating breaks out. Either way, it's going to give us that FLC of 50 amperes. Okay, so let's write that down real quick. Let's put it in there. 50 amperes out of the back of the book. Okay, next step that we are going to do is we're going to want to size the overcurrent protective device. Remember, the size of our EGC is going to be based on the size of the overcurrent protective device. Okay, so let's head over. We're already in 430, so I'm just going to do a power scroll. Since we're touching on this later, I'm not going to worry too much about it. I happen to know what the chart looks like, so I'm going to show it to you. I believe it's in 52. We're almost there, probably. Yeah, there you go, 52. Table 430, 52C1, maximum rating or setting of motor, branch circuit, short circuit, and ground fault protective devices, okay? We are going to find the type of device we have. In this case, it's going to be a dual element time delay fuse. We are talking about single phase motors, and we do have a multiplier of 175%. Okay, so let's back over to the question and let's do a little multiplication. We're going to take that 50 times 175%, which we will express as 1.75. Okay, let's math that out. Here we go, over to the calculator. 50 times 1.75 equals 87.5, which we will take up to the next standard size overcurrent protective device, which is 90 amperes. You can always verify that in 240.6. I'll write that in there, 240.6. Cool. We got that. So let's go over and check what size equipment grounding conductor we would put in this circuit. Okay, so we will head to 250, 122. 250, 122 is going to be our table for sizing equipment grounding conductors right here. Minimum size equipment grounding conductors for grounding raceway and equipment. Okay, and we have 100 amp here. Okay, we have exceeded the 60 and all the others, so we'll need to go up to that next one. And a number 8 is good up to 100 amps over current protective device. Number 8. Now, I do want to give you a caveat on this one. Okay, and I'm going to say this because they gave you this question, it panned out that way in this question, but one thing you're probably going to want to do when you're doing a question like this is double check the size of your conductors, because we do have the circumstance and situation where we don't have to exceed the size of the circuit conductors, okay, for an equipment grounding conductor. So we can find that bit of information back here in 250.122. Okay, it says right here, copper, aluminum, or copper clad aluminum equipment grounding conductors of the wire type shall not be smaller than shown in the table we just looked at. But it also says the equipment grounding conductor shall not be required to be larger than the circuit conductors supplying the equipment. Now, occasionally, when you're doing a calculation like this, and this happens a lot with the little bit smaller motors, where you could have a number 14 on a 30 amp breaker, right? Remember those situations with motors, and we'll talk more about it later. But that 30 amp breaker would say, hey, I need a number 10 ground, but I have number 14 ungrounded conductors. In that circumstance, I don't ever have to be larger than the ungrounded conductors. So if it's a 14 gauge circuit conductor on a 30 amp breaker, I'm going to put in a 14 gauge ground, because that very second sentence or whatever it was inside of 250.122 allows me to. Okay, so the EGC equipment grounding conductor is not required to be larger than the circuit conductor supplying the equipment. There you go. Okay, so just keep an eye on that when you're going through these. It doesn't apply to this question. If you were to math this out, you'd be fine, right? 50 amps times 1.25, 50 amps is about our number 8, right? Okay, so it's not going to quite work out, but we'll do some more of these as we get down the train. So hopefully that helps you out if you're struggling with these ones, and if not, don't worry, we got more coming.